So here's a problem that I want to do partial derivatives with. And let's start off with this first part. The partial of w with respect to u will be w with respect to u. The power rule, the 1/2 comes to the front. I'll have u squared plus v squared unchanged. And then what's the new exponent? -1/2. And then you have the chain rule. What's the derivative of u squared plus v squared? 2u, since v squared is being treated as a constant. So there's the first one. I could simplify this, and maybe I should. 1/2 times 2 is 1. I'm going to write the u first. U times u squared plus v squared to the -1/2. And I suppose you could write it as a fraction. Drop that u squared plus v squared to the -1/2 down to the denominator, but I'm not going to do that. The second part of this problem is to find the partial with respect to u and then u again. What rule do I need? I need the product rule. So this is why these problems, sometimes they can get a little out the box crazy. See, I have u times this expression that also has u. So we'll do the product rule. What's the derivative of u? It's 1, because I'm doing the derivative of u with respect to u. And then I'll have 1 times, keep the second function, u squared plus v squared to the -1/2, plus, this time, keep u and do the derivative of u squared plus v squared to the -1/2. So we'll keep the u. Now take the -1/2, bring it down to the front. We'll have u squared plus v squared to the -3/2. And what else? Chain rule. What's the derivative of u squared plus v squared? 2u. Now there's my answer. You can clean it up if you like. I'll clean it up. Although if I put a box around something, if you got that far on the test, to me that's full credit. So if I simplify it a little bit, this partial derivative of w with respect to u and then u again, 1 times, well that's just u squared plus v squared to the -1/2. Here I have a -1/2 times 2. That's going to be a -1. And I can do u times u. So it's going to be minus u squared times u squared plus v squared to the -3/2. There's my simplified answer. I guess we could simplify it a little more, but let's not. For the other part of this problem, here, part 3, I want to find the derivative of w with respect to u and then v. So I'll have this going on. W with respect to u and then with respect to v. We're using this answer. This time, u is a constant. So this u times, open parentheses, u squared plus v squared to the -1. This u is a constant. It's just like having a 4 or an 8 or a 9 right there. What do you do in that case? You just keep it, right? So u, the constant, times the derivative of this part, which will be negative 1/2 times u squared plus v squared, use the power rule, to the negative 3/2 times what? What's the chain rule give me? 2v. There's my answer for the derivative of u and then with respect to v. If you want to clean it up, negative 1/2 times 2 is negative 1. I will write the u times v first. U times v times u squared plus v squared to the negative 3/2.
Wouldn't that be a negative?
Oh, it is. Thank you. Is that what y'all's hands are up for? Yes.
Okay, so for all these problems, they always like ask you to get one that they want you to find.
Yes. They'll ask.
There's like no overall answer.
They'll ask for specific partial derivatives. And there are 4 second partials. Yes.
So since one of these variables can be treated as a constant, what happens
Could you use trig substitution?
since that one of them is treated as a constant, and see how that says a squared,
Right?